All right, guys, welcome back. We've spent a lot of time focusing on the graph of sine, okay? But now that we are, and that was intentional, I wanted to make sure we felt really good about all the different ways they can be adjusted, the period, the midline, amplitude, all that, shifting left and right, uh, flipping it, all that stuff. It makes graphing everything else after it really simple if we are experts at one to start with. So as slow as we went through sine last week, we're going to cruise through cosine, secant, and cosecant all today. So it'll pick up a little bit. But to maybe introduce sine and cosine to you, I think, or cosine to you, it may be helpful to look back at sine. So I'm going to do in two different colors here the graph of sine of x. Okay, and I'm just going to plot the quarter period points. Remember sine started at, right, 0, 0. This is just a regular sine, right? Then we went to pi over 2 comma 1. Then we were at pi comma 0. Then we went down to 3 pi over 2 negative 1. And then we finished at, right, 2 pi comma 0. And it took that general wavy shape, right? And we talked about that. It kept going on forever. That wavy shape would just keep repeating and repeating and repeating. But we only graphed one function, or one period of it, excuse me. So the question is, well, how does cosine different, right? How is it different? So let's do this in a different color. I'll do it in blue. Y equals cosine of x, and I'm really just going to think of the values of the unit circle, right? Those quadrantal values, and just get a sense for what cosine looks like. So we know sine, right, at 0, and maybe it's even helpful since it's been a while since you've done this, right? We have the point 1, 0, 0, 1, negative 1, 0, 0, negative 1, and I would remember this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is also, 2 pi. Right, so those are the angle measurements for each one of those points. Well, what is cosine at 0 radians? Well, cosine at 0 radians is actually 1. Okay, it's 1. So actually, my cosine point starts up here at 0, 1. And one thing I should have done at the beginning, if I was paying attention, was labeling my midline. So notice that sine, right, starts on your midline. Where does cosine start? Think about that in relationship to the midline. Cosine, right, cosine starts the amplitude above the midline. Sorry, the writing there is a little messy. Cosine starts amplitude above the midline, whereas the sine graph started on the midline. All right, let's go to pi over 2. And again, I'm kind of just looking back over here. What's cosine of pi over 2? It's 0. So cosine of pi over 2 is 0. So this point is pi over 2 comma 0. At pi, cosine is negative 1. So pi negative 1. At 3 pi over 2, cosine is 0. And then at 2 pi, cosine value is 1. So I'm kind of right back where I started, 2 pi comma 1. And if I were to connect this graph, I would get something that kind of looks like a upside down bell or a valley of some kind. But think about it, how does it really compare to the sine function? Well, again, remember, I'm going to see how well I can do this, that these graphs just continue on forever. So if I were to continue on the cosine graph and the sine graph, okay, I might have not done it justice, but it's really, the cosine graph is really identical to the sine graph, except it's shifted over just a little bit. You can imagine if you shifted that graph in blue, pi over 2 to the right, all the points over pi over 2, all the points would line up to each other. And I tried to display that graphically. It's not perfect, but it's close enough that I think you can visualize that that blue graph would be right on top of the graph in black, except if you shift it over pi over 2. So just notice when you graph cosine, you're really just starting at a different point on the curve. You're starting at the max point, whereas sine graph, you're starting on the midline. But other than that, the shape is the same. You're just plotting a different section, right? A different section, basically. But you still complete one period, right? You still go from 0 to 2 pi. So in a lot of senses, it's similar. In a lot of sense, it's different. So at the bottom here, we talk about key points for sine and cosine. I'm not sure it's super helpful to run through them, other than maybe a few of them, just maybe some similarities. Visually, if you can visually see the difference between them, that's all that matters. Notice that the period is the same for both the max and the mins. Oops. The max and the mins are the same for both. Okay. Y-intercept, they're different, right? They're clearly different. The domain, though, for all of them is negative infinity to infinity. The range is negative 1 to 1 for both. Okay. And just notice that the roots would be different. I don't know if it's worth our time to list out all the roots. You can kind of see where they cross the x-axis. Okay? But notice there's a lot of similarities. Okay, a lot of similarities there. All right, so let's start. Why did it do that? Sorry about that. Let's start graphing this. Let me erase this. Okay, and just remember some of the differences. So we're going to, in terms of analyzing the cosine graph, it's going to be the same as the sine graph. So the amplitude, there's an invisible 1 in front. The amplitude is 1. The period is going to be 2 pi over b, which in this case is 2 pi over 2, which is pi. Okay, which means the quarter period is pi over 4. The midline, there is no vertical shift, so it's going to be y equals 0. To find the starting value, we're going to take what's inside, 2x minus pi over 2, set it equal to 0. You get 2x equals pi over 2, or x equals pi over 4. And is it flipped? It is not. So again, let me do it in a different color so I can distinguish between the axes. There's no vertical shift, which means my midline is going to be at y equals 0. Always plot the midline first, no matter what graph you're plotting. Okay. And then my starting x value is pi over 4. Okay, it's pi over 4. Now, normally, my sine function would start on the midline. This is a cosine function, so I'm going to start, how far above the midline am I going to start? I'm going to start the amplitude. So the amplitude is 1, so I'm going to start the amplitude above the midline at pi over 4, comma 1. And this works out quite nice. I'm just going to add a quarter period to my starting value. So a quarter period, okay, just so I don't get confused here, I'm going to erase that part. My quarter period is pi over 4, out of pi over 4 to pi over 4, and I get pi over 2. And remember that pattern of max, midline, min, midline, max. I'm going to go down to my midline, and that brings me to pi over 2, comma 0. I'm going to add another quarter period, and that's going to bring me to a min. So 3 pi over 4, comma negative 1. Add another quarter period. That's 4 pi over 4, or pi. 0, and then add another quarter period. That brings me to 5 pi over 4, comma 1. Right, and then there is my, should not be such a sharp V at the bottom as I drew. So it should be a little bit smoother. But there is our graph. And again, one way I can check, one of the things I can check is my ending value minus my starting value equal to the period. That's equal to pi. So check, that's good. It's not flipped, so on and so forth. Okay, So that is your basic cosine graph, okay, with a little bit of adjustment. I would encourage you now to try problem 2 by pausing it. Pausing it, there's a lot going on. We kind of go from 0 to 100 really quickly on these cosines, but approach it the same way you would a sine graph. Okay, and just remember that normally a cosine function starts amplitude above the midline. Okay, notice this problem has a negative in front, so I'll let you kind of think for a minute about what that might mean. But pause it, try it for yourself if you can, and then hit play and see if you match what I got. Okay, so here is our graph. Y equals 3 minus 1/2 cosine of pi over 2x minus 6 pi. It might be easier to think of that 3 here on the right. Okay, so it's negative 1/2 cosine. A little bit more easy to see that this is has a midline of 3. So amplitude is always positive. So in this case, the amplitude is positive 1/2, even though there's a negative. The period would be 2 pi over pi over 2, which is the same as 2 pi times 2 over pi, which is going to be equal to 4. Interesting, which means the quarter period is 1. The midline we just talked about is 3. The starting value, pi over 2x minus 6 pi equals 0. Pi over 2x equals 6 pi. Okay, which means x, okay, is equal to 12. The pi's cancel out. And then is it flipped? Yes, it is flipped. Okay, so we're starting at 12. So we're an x value of 12, excuse me. So we're starting clearly to the right of the y-axis. And actually, I should heed my own advice before I do anything. I should plot the midline. So let's plot the midline of 3. Because again, everything is all in relationship to that midline. So I'm going to start at an x value of 12. And since this graph is flipped, that means instead of starting above the midline, I'm going to start below. If you started below, give yourself a pat on the back. So we're going to start the amplitude below the midline, which is 1/2. So I'm actually going to start at a y value of 2.5. So I'm going to start somewhere here maybe, and that point would be my starting x value of 12, and my starting y value of 2.5, or 5 over 2. Okay, I'm going to add a quarter period and go up to the midline now, and that's going to take me to 13, 3. I'm going to add another quarter period and go to a max. That's going to bring me to 14, 7 over 2. Add another quarter period. That's going to bring me to 15, 3. And then another quarter period. That's going to bring me to 16, 5 over 2. And then if we make a nice graph. Okay, again, not perfect. There's a reason why I'm not an artist. We get a graph that looks like that, but that one kind of looks like a hill or a bell. Okay, I'm looking at my ending minus my starting value, 16 minus 12, that matches the period, that's great. Midline is 3, is it flipped? Yes, all that looks great. So if you got that, great. If you didn't, make a careful note of where you went wrong, and hopefully you won't make it again. All right, number 3 asks us to graph another cosine one. We're going to hold off on that one for now. If you want to try that one on your own time, feel free to do so. I will post the solutions to this tomorrow, so you'll have all the stuff you need for that then. But you can certainly give it a shot now if you'd like. Okay, so that's cosine. Told you we'd fly through it pretty quickly. Now I want to graph cosecant and secant, and we'll start by graphing cosecant. And it might be helpful to remember, okay, that since we're graphing cosecant of x is really equal to, or let me reverse that. Yeah, sorry, I'm thinking this through as I'm doing this. Yeah, let's try to remember that cosecant of x is really just the reciprocal of 1 over or is the reciprocal of sine of x. Cosecant of x is just 1 over sine of x. And secant of x, okay, is equal to 1 over cosine of x. Okay, so it's helpful to remember that relationship. So I wrote here, when graphing secant and cosecant, it's actually helpful, believe it or not, to graph cosine and sine first, and then create your graph for secant and cosecant. So I'll show you what I mean by that, okay? So it asks us to graph cosecant of x. I'm actually going to graph cosecant of x by graphing sine of x first. It's reciprocal. So in terms of amplitude, period, and all that stuff, I'm thinking sine of x, the amplitude is 1, period is 2 pi, quarter period is pi over 2, midline is y equals 0, starting value is x equals 0, and it's not flipped, right? So that should all be straightforward. So I'm going to plot the points, 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma negative 1, and 2 pi, comma 0. And this is not my actual graph here. So what I'm going to do, since it's not my actual graph, is make it dotted to indicate that that's really not the graph, the answer I'm giving. And in fact, if you have a different color, you can use a different color. I'm going to switch up colors here in red to make it clear that my red graph is my cosecant graph, okay? But all I did was graph sine first. And you might be saying, oh, how is that helpful? Well, let's again go back to this relationship that cosecant and sine are reciprocals of each other. Meaning, if sine of 30 is equal to 1 over 2, I'm just picking a value, then cosecant of 30 is equal to the reciprocal of that, 2 over 1 or 2, right? So I can find the value of cosecant by just taking the reciprocal of sine. So let's actually start with all the intercepts at 0, 0, pi 0, and 2 pi 0. The question is, what would the reciprocal be of 0, of these points right here? Now remember, the way we found these values was using the right triangles where the hypotenuse is 1. So really, when we say that the value of sine of, for example, 2 pi is 0, we're really saying it's 0 over 1 or 0. So what would the reciprocal of 0 over 1 be? It would be 1 over 0, which would give us undefined. So at any of these points, okay, I'm going to go back and label the midline. At any of these points where the sine graph hit the midline, I'm going to get undefined values for cosecant, for cosecant. And if you remember back to your rational functions days, the last days of the Ms. Austri, or some of the last days of Ms. Austri, when you divided by 0, you had something undefined. Graphically, those created vertical asymptotes. So what we're going to have here are vertical asymptotes at 0, at pi, and at 2 pi. And you can imagine that as the graph continued, and every intercept, or every time that graph crossed the midline, okay, I would have a vertical asymptote. So that graph in red is part of my cosecant graph. I have vertical asymptotes there. Now let's take a look at the other points. At pi over 2 comma 1, what is the reciprocal of 1? Well, it would be 1. So cosecant of pi over 2 is 1, as is sine of pi over 2, so they share that point. And consequently, for the same reason, they share this point down here as well. Well, let's just go back and think about this reciprocal thing now. We're almost done, believe it or not. If I look at this part of the curve, I'm going to go back to black so I don't confuse you. Okay, right here, you can see that part right there on the sine graph. It's getting thicker. What's happening to all those y values? All those y values on sine are getting smaller. Okay, all those y values on sine are getting smaller. And if you think about this, if cosecant is 1 over sine, and those numbers for sine of x are getting really small, when I have a fraction and it's 1 divided by a really small number, what do you get? You get a number that's really big, right? For example, what's going to be bigger, 1 divided by 10 or 1 divided by 1/10, right? 1 divided by 10 is 1/10. 1 divided by 1/10 is 10, right? So the smaller the denominator is, the bigger the value is. So if I'm thinking, well, my sine graph's just going to be 1 divided by, go back to black, 1 divided by all these values here, and those numbers are getting smaller, that means my cosecant graph should be getting bigger. So what's going to happen is, well, what happened there? What's going to happen, right, is I get something that almost looks like a half a parabola there. That reason that cosecant graph is so large is because those sine values are getting really small. And consequently, you can imagine this would happen on the other side as well. And what you get is what I like, especially with my younger classes, we call them just mini parabolas. They're not technically mini parabolas, but they certainly look like them. Okay? So that's one part. But we still have this other section we haven't filled in. But for that same methodology, if I take a look at the right side here, all those sine values are getting really, really small from a negative perspective. So what's going to happen to these values for cosecant, they're going to be really large in a negative perspective. I know they're technically getting smaller, okay, but you're going to have that same parabolic look to it because I'm dividing it by a really, really small fraction, or a large negative fraction, excuse me, okay? And again, you can imagine if I continued this, I would have another upwards parabola over here, another downward parabola over here, and so on, and that part would just repeat. Okay, that part would just repeat. So there is your cosecant graph. I want to go to, why is it doing this? I want to go to my secant graph now, and then that should be more or less it. So now I need to erase all this. Okay, this should be a little bit quicker to graph now that we know the cosecant graph. All right, if we're going to graph secant, we're going to graph, you can guess first, cosine, right? So we're going to graph cosine of x. First, amplitude 1, period 2 pi, quarter period pi over 2, midline 0, starting value 0, and is it flipped? No. Okay, so remember, your cosine function starts above the midline, then goes down to the midline, then to a min, and then to a max. I'm not even going to label these points yet. I'll get to that in a minute. Okay, and notice, and I'll show you why in a second, I'm going to keep on going and graph one more midline point for cosine. So I graphed one period, and I'm also going to graph one extra point. And you'll see why in a minute. And actually, you know what? Why don't I actually plot these points to make our lives a little bit simpler. So we have pi over 2, comma 0, pi, comma negative 1, 3 pi over 2, comma 0, 2 pi, comma 1, and 5 pi over 2, comma 0. So there's my cosine graph with an additional point plotted, and you'll see why in 1 second. I'm going to graph secant in red. Okay, I know I'm going to have, for the same reasons cosecant did, I'm going to have asymptotes anytime my graph crosses the midline, which is going to be here at pi over 2. It's going to be here at 3 pi over 2. And notice why I graphed that last point was I want to have 3 asymptotes. And notice on a normal cosine function, you don't have 3 points where the graph crosses the midline. In order to have an asymptote, you need the graph to cross the midline, hence why I needed to graph that extra point. Okay? And notice, if you label your points really well in your cosine function, you don't need to label any more additional points on the secant function. I know they're going to share this point. Okay, and we're going to have that little mini parabola, right? this many parabola, they're going to be tangent at the maxes and mins of cosine and sine, and that's all you need to plot. Since they share the same point, I don't need to relabel the point again. Okay, so there's your graph of secant. All right, so let's try to do one more together, and let's do 2. And I would actually encourage you, if you think you want to give 2 a shot, maybe do it in pencil first. Okay, do it in pencil and see if you get the same thing I did. Just a little hint though. Again, plot cosine first, but plot cosine of all this information. Don't just plot regular cosine. Plot 1 plus cos 4 cosine of 8x plus pi over 5. Plot that, okay? Plot that first, and that will help you easily graph the function here. And actually looking at this, it's going to get a little bit messy. So if you need to use a calculator to help you do some of the fractions, feel free to do so. This one gets kind of crazy. Okay, so hit pause if you'd like to. If you want to just do it with me, you can do that. Okay, so amplitude in this case would be 4. Period would be 2 pi over 8 or pi over 4. Quarter period is then pi over 16. Midline is 1. Starting value, all right, this is going to get a little crazy. 8x plus pi over 5 equals 0. That means 8x equals negative pi over 5, or x equals negative pi over 40. Thanks a lot, Mr. Bodner. Negative pi over 40 and pi over 16 for quarter periods, that's going to be a pain. And I don't disagree. It will be. And is it flipped? No. Okay, it's not flipped. So again, we're going to graph cosine first. We're going to graph the midline, okay, of y equals 1. Say y equals 1. Well, I'm going to start at negative pi over 40. And remember, I'm going to start above the midline. Okay, I'm going to start above the midline, which would bring me to negative pi over 40. Okay, comma 5. Right, so this point here, negative pi over 40, comma 5. Now I'm going to add a quarter period to it. To find a common denominator is going to be kind of a pain. So to do that, I'm just going to multiply 16 times 40. And I get 640. So pi over 16 and 40ths, okay, is 16 pi over 640. And then negative pi over 40 is negative, hold on a second, am I screwing this up? The quarter period, sorry, that would be 40. That's 16 pi over 40. 40 pi over 640, right? Sorry, I'm doing this in my head too. I'm just double checking. Yeah, 40 pi over 640. And then negative pi over 40 would be negative 16 pi over 40, okay? So adding a quarter period, so this is really negative 16 pi over 640. Okay, so adding a quarter period to this, that's going to bring me to positive 24 pi over 640. So that brings me somewhere here. Okay, 24 pi over 640, comma 1. Go down to a min. Make sure you go below the x-axis. At this point here, I'm going to add another 40. So that would bring me to, what, 64 pi over 640? Again, normally I would say reduce, but in this case, it's kind of crazy. The numbers here are kind of crazy, and I don't want to get too bogged down on simplifying rational or fractions. So don't worry about that here. 64 plus another 40 gives me 104. 104 pi over 640, comma 1, and I've got a max, okay, of let me add it again, plus another 40, 144 pi 144 pi over 640, comma 5. And let me give myself a little bit more room here, because I do need, remember, a third point on the graph, or third point on the midline. I'm going to have this point here. This would be another 40. That'd be 184 pi over 640, comma 1. Whew. Okay. So I'm going to make my... You might realize over time you actually don't need to graph this dotted line. I like to do it. But you do not have to. If you don't want to, you can just leave the points. So there's my graph of cosine. Now I'm going to get to my graph of secant, which at this point should be pretty straightforward. I'm going to draw my asymptotes through points on the graph where it crosses the midline. Notice not where it crosses 0, but where it crossed the midline. And we're going to label them, but I've already labeled the points, so it makes it really easy. X equals 24 pi over 640. X equals 104 pi over 640. And x equals 184 pi over 640. And I've already labeled my max and min points on the cosine graph, so that makes graphing, oh boy, that's bad. Let me fix that. Okay. That's a little better. Makes graphing the secant function a little bit easier. Okay. Not the neatest graph in the world, but there we go. So you can see it's really, most of the work is graphing cosine, or sine first, and there's just a couple extra steps to graph secant and cosecant. Okay, so if you feel like you want to try number 3, feel free to do so. The homework tonight only covers sine and cosine. It's worksheet number 15. We'll do more graphing of the cosecant and secant in class on Wednesday, but I wanted to introduce it to you so you have a sense of what's coming up, okay? So homework tonight, worksheet 15. I will put the solutions for that online, but I do want you to check it in your group as well should you have questions, okay? So email me if anything pops up. Otherwise, we'll see you guys on Wednesday.